Okay, so yeah, so here we are. So the base stays the base. So we change to log. Change to log. The rule is the base stays the base. The other two switch. So who's the base? The 6. He's the one that's low down, got something on him. So then he'll become the base, the lower down part of the log. The base stays the base. The other two switch, meaning the 216 and the 3 will switch roles. What was the 3's role? It was 6 to the third power, right? So instead of 6 to the third power, it'll come out looking like 6 to the 216. It's not really that, but it sort of looks like that to remind you that this logs are about powers. What logs really are, we'll see very clearly today, is inverse powers. That's what logs are. Logarithms are the inverses of exponentials. That's what they're inverse powers. So we'll see that crystal clear today. So, does that make sense? Base stays the base, how did you switch? So I got it. Base stays the base, how did you switch? So there is a lower down part on a log. That's the base. And you would type that in to Math Excel. You got to do the subscript thing. You know what I mean by that? Okay, so here's number 3. So it's log base 9, 81 is 2. So this time we're translating the other way. We've got a log. We're starting with the uno, and we want to go back to the 1. We're going from log back to regular. What's the rule there? Same rule. Cross out the log. When you lose a log, the base stays the base. The other two switch. Same thing. So whether you gain a new log word that wasn't already there, or lose a log word that was there, either way, base stays the base, other two switch. It's the same rule going in or out of the log language. So cross that out. The base, the 9, continues to be the low down number. And that looks like 9 to the 81. They switch. 9 to the 2, 81 goes there. And that's like, it's like obvious. You know that, huh? 9 squared is 81. Well, the log says that's what I was saying all along in my log language. But we don't speak log language naturally, do we? So we want to translate out of log language. Good? So log base 901. Okay. So every log expression has 3 parts. It has the base, which is 9. It has the argument, they call it, the number that comes right after the 9. And then they're supposed to be equal, and there's supposed to be something over here. There's supposed to be 3 parts. Everybody with me? So that third part is missing. So what am I going to do? Call it x. Did you catch that? Let me let you digest that for a second. Every log statement really has 3 parts. So if any of those 3 parts are missing, fill them in. And in this case, what it equals is missing. So I just call it x. Just giving it a name. So they all have a base, an argument, which comes right after the base, and then what it equals. So, okay, so great, it equals x. What does that do for me? Well, how can I solve that now for x? What could I do?
Turn it back to exponent.
Yeah, turn it back to exponent. I could lose this log, huh? Because I can't really read log expressions. I don't speak log. But I can just translate back to English here. Just cross off that log. What happens? Base stays the base. Other two switch. So who's the base?
9.
The 9. The 9 is the base. The other two switch. The 1 and the x switch. Well, instead of 9 to the 1, it's 9 to the x, and the 1 goes over there, huh? I translated out of the log language. So now you tell me. What does x have to be to make this true? Yeah, 9 to 1 power is 1. 0. Remember that? Remember anything to the 0 power is 1? So x is 0. Is that good like that? Now, let me give you 2 ways to that. That was a fine way to do it. There's another way. Well, here, let's just leave it like that for now. I'll give you the other way in a minute. So log base 1/2 of 32. So try that one. He's missing one of his parts, right? He's missing the right side. So just write equals x. Like we did in the last one. And then lose that log. Cross off that log. Base stays the base. Other two switch. equals x. Cross off the log. Base stays the base. The other two switch, so the half continues to the base. The 32 and the x switch. Instead of half to the 32, it's half to the x, and 32 goes over there. Good so far? Now it's like, okay, yeah, but what's that? Yeah, let me let you think about that for just a minute. I would take, you know what I would do? I take my cat, take 2. Forget about the half. Just take 2. And take 2 times 2 times 2 times 2 until you get 32. So just take your cat. Forget about the half. Just take 2. And find out how many 2's multiply to be 32. 5 2's, right? You get that? 2 times 2 times 2, 5 times is 32. So if this just said, if it said 2 to what power is 32, we'd say, well, 5. 2 to the 5th is 32, right? That'd be our answer. But instead it says a half. Yeah, what can take that half and flip it and make it 2 over 1 or 2? Negative. Remember, negative powers flip things? So they're testing you here if you remember the rules from algebra about negative powers. Yeah, so our answer is negative 5. Because if you make that negative 5, the negative part of the 5 will flip it, make it 2 over 1 or 2, and then 5th power, 32. It's negative 5. So whenever they have something that needs to be flipped, that just means your power is negative. Negative powers flip things. Remember that from algebra? Negative powers flip things. They don't put negatives in the front, do they? They flip things. Negative powers flip things. Let me write that. I don't know. Did we talk about that last time? I can't remember. Okay, so I'll just go x to the minus n is 1 over x to the n. It becomes positive after the flip, huh? I think, oh, yeah, it's just right. Did I say it's like somebody's unhappy at their job? Right? They're negative. They don't like their job. Then they flip to a new job. Then they're positive. Then they're happy. So that's what I always tell my algebra students. Negative powers flip. They're negative. They're unhappy. They flip. All right. Rule here. Pre-calc and calc make you a master of algebra like you never really wanted to be. No, thought you could be. Log-based root of 2 of 4. We solve that. Put equals x again. Equals x. Lose the log. Equals x, lose the log. Base stays the base. The other two switch. Instead of root 2 to the 4, it's root 2 to the x. 4 goes over there. Now you can just kind of think about how many root 2's, what power on the root 2, how many root 2's would make 4? We can just start writing them out, huh? What's root 2 times root 2? What's 2 of them? That'd be a plane 2. Remember that? And so that is plane 2. So then if you do 2 more, that's another plane 2, and 2 times 2, that'd be 4. So we need how many of them? We need 4 of them. This power has to be 4, doesn't it? 4 root 2's makes regular 4. Does everybody see that? Do you remember that from algebra? Root 2 is root 4, or 2. Plane 2. Do you see how I'm coming up with that? I don't want to just say this and leave you high and dry. Does everybody see what I'm saying there? Think about roots with me for a minute. What is root 2 times root 2? Well, it's root 4. 2 times 2 is 4. And what is the square root of 4? Plane 2 with no more root. Huh. Whenever you have 2 identical roots, it ends up being one plane one, doesn't it? Everybody with me on that? What if I had like root 7? What would that be? Well, root 49. And root 49 is plane 7. See how 2 of the same thing is one of those plane? See how that always works? 2 of the same root is one plane whatever, isn't it? So 2 root 2's is one plane 2. 2 more root 2's is another plane 2. 2 plane 2's is 4. So how many of these do we need? You need 4 of these to make plane 4. Good? All right. Okay, so we have this function, I'm just going to call it y. Y equals log base 7 x to the 9. Log base 7 x to the 9. What have we done with domain up to now? It's time for something new. What do we know about domain up to this point? How do we handle domain? What are the two things we look for? What are the remember, domain's problem areas, right? What are the problem areas we look for? The things that we have to say, hey, you can't do that. It's going to cause a problem. Zero denominator, right? Denominators cannot be zero because that'll cause a problem, right? That's one of the main things. What's the other main thing we look for?
Square root.
Yeah, any even root, the inside, we always say, hey, inside, you cannot be negative. You got to be greater than or equal to 0, huh? For any even, odd roots, we don't have a problem. Odd roots can be negative inside. Remember we talked about that? So even roots can't be. They have to be greater than or equal to 0. They can't be negative. That's all we've had so far. It's time for a new, and really the last piece of the puzzle. Logarithms have a problem with certain things. You guys have your calculator with you? Hit log of 0. What's the log of 0? It's an error. Oh. You guys getting that? Log of 0, undefined or error. Yeah, real fast, I'm going to say infinity. Did we get an infinity? Did we get an infinity? All right. So most of them say error, undefined, or whatever. Well, how about log of negative whatever? Log of negative 1. Error. Again, it's going to be error. So the point is, you cannot put negatives or 0 inside of a log. Just kind of like well, I don't know what that's exactly like, but so if you have a log, any log, and you have the inside, you have what you're plugging in, the argument. It has some base. Who cares about the base? I'm just talking about the inside. The inside of a log must be greater than 0. Not greater than or equal. It can't even be equal to 0. Not equal to 0, not negative. You cannot put negative or 0 into a log.
So it's like if the x was the denominator of like the equation and it was also the square root.
Yeah, that would work, huh? Yep. So we say, okay, so that means this piece right here, this x to the 9th, that's the argument, the part that comes right after the base, right? Here's the base, and I'm talking about this part that comes right after the base. That part must be greater than 0. Tracking with me? That part must be greater than 0. Well, how is x to the 9th greater than 0? Well, it just means x is greater than 0, right? With me on that? Any positive, you put in any positive number here and raise it to the 9th power, it's going to be positive. Is that okay? Am I doing the Charlie Brown teacher, the 111, or did that sentence I just said make sense to you? This is saying, when is x to the 9th positive? Right? Greater than 0 is a way of saying positive, isn't it? So if I said, hey, for what x's, what numbers can you put in? What number can you put in and then raise it to the 9th power and it'll come out positive? Well, any positive number. If you put in put in 2 to the 9th, that'll be positive, right? Positive 2 to the 9th. Any positive number times itself 9 times will be positive, won't it? 0 won't work. 0 times itself 9 times is just 0. A negative number times itself 9 times would be negative. An odd number of negatives would be negative. That won't be positive. So that just means the number itself, x, must be positive, greater than 0. Good? That's our answer. That's the domain of that log. So it's all positive real numbers. What's that? If it was even, that'd be a harder question. Yeah, what would it be? What if it was even? What if it was x to the 8th? It could still be negative, right? Because if your 8th power, negatives, any negative number times itself 8 times would come out positive, wouldn't it? So it could be negatives or it could be positives. What could it not be? 0. That's the only thing it couldn't be, because you can't be 0, but you could be all positives and all negatives. Yeah, if that was an even power, if we had, in fact, they might. Do they do that? Do you guys have the math Excel open right now? Maybe it'll do even power. Does it do even power? So if it was x to the 8th, we would say x not equal to 0.
Yeah, it's a wrong answer.
All non-zero real numbers?
Yeah, that's what it would be. It would be all non-zero real numbers if it was an even power. If it was an even power. Does that make sense? If it was an even power, it can be anything that's non-zero. Anything but 0. Is that good? We making sense on that? Because even powers come out positive, whatever you put into them, except for 0.
Yeah, but they gave you an even question.
What's that?
Yeah, I didn't give you an even question.
Did they give you an even one? Yeah, some of them do. Mine's given odds, it's
So
random.
interval notation for this question, be 0, infinity, then, right?
For this one, yes, 0, infinity. N is just another kind of log. Don't need to do anything special with that. So this is ln of 1 over x plus 8. Y equals. All right, so try that one. Find the domain. They're asking domain again. Try that one. Can I challenge you? I'm gonna bet that I don't know how many people will get this one right. You might get this one right. Yeah, this is a little tricky. Try this one. Think about how to do that. What's gonna make that work? This is a tricky one. But you can do it. You have this stuff, but it's tricky to remember it all. L is just for a different kind of log. Just pretend that says log. It's to say ln is just a log with base e. That's all it is. Anyway, just pretend it says log. Nothing special about that. Just pretend it says log. Same thing. So what do we learn about domain? The inside has to be the inside of any log. Ln is just a specific kind of log with a base of e. We'll talk more about that. So the inside, we say inside, you have to be greater than 0. So far, so good? Right, this is what you always do. For the inside of a log, any log, ln, whatever, greater than 0. Not 0 and not negative, huh? Greater than 0, positive only. Good so far? So now, can you solve that though?
The bottom has to be greater.
How do we find that? What's going to make this greater than 0? Positive, in other words. What's going to make that fraction positive? The top of the fraction is already positive, huh? So if the bottom is also positive, then the whole thing will be positive, right? So as long as the bottom is positive, that's positive. Greater than 0 is another way of saying positive. Right? You with me on that? If I say greater than 0, I'm saying positive. So I'm saying, hey, the top's already positive, so if the bottom is positive, then it's positive over positive, the whole thing's positive. So really it's just bottom being positive, and then solve for that, you move that over, x is greater than negative 8. As long as x is greater than negative 8. Yeah. When you're thinking the negative 7 thing, I heard that's a good thing to mention. The only thing that's mistaken with that is there's numbers between negative 7 and negative 8. Like what about negative 7.3? That needs, right? If you think about the number line, here's 0, here's negative 8. It doesn't quite hit negative 8, but it does go past negative 7. It's all these numbers. So there are numbers between negative 7 and negative 8. So you can't just say negative 7, because you wouldn't include like negative 7.5 and negative 7.9, and right? It's everything right up to negative 8, but not quite touching the negative 8. So anything bigger than right of negative 8. Does that make sense on that? Any number you put in there bigger than negative 8 will work. I've put in negative 7.5. You see that bottom will be positive. 8 minus 7.5 is positive a half. And the whole fraction will be positive, and then that's okay then. The inside of the log is positive, so that's okay.
If it was 1 over x minus 8.
Yeah, if it was x minus 8, then I would just have x minus 8 greater than 0, jump that over, x greater than 8. On that. Just got to make that bottom positive. Whatever they put in the bottom, that bottom has to be greater than 0. Do you have your calculator? Hit ln of 16/7. I'll do it too. ln is, yeah, it's on the left side over there. I'm getting 0.8266. I don't know how many places they want. 3 decimal places. 0.827 then. Y'all getting that? You okay with that? All right, I'm going to move on. You have any calculator trouble, grab me after. Let me mention something about calculus. If I let's do it this way. What if I go 4 over 2? What does that equal? What's 4 over 2 plus 2 equal? Yeah, it's 4 over 4. It's 1, huh? If I type into my calculator 4 divided by 2 plus 2, will it tell me 1? If I type that in, is that the same as that? No. Correct. Do you all know that? That's not the same as that? Why not? What's the problem with that?
Operations. 4 divided by 2 2.
Yeah, it'll do this first and get 2, and then add 2 and get 4. Do you see the problem? The only way you're going to get it to know that both these are in the denominator is to parenthesize them. Then it'll give you 1. Then it'll know, oh, these guys go together. Okay, 4 divided by 4. So my point in that is, whenever you're typing anything into your calculator, if you have more than one item in a numerator or denominator or power zone, any of those 3 zones, worlds, numerator, denominator, or power, you want to parenthesize it. So put parentheses around this numerator and parentheses. That's going to be in addition to the little parentheses that your calculator automatically puts on little log things. So you end up with a fair number of parentheses there. Are you tracking me with all that? So that's what you want to type in here. I'm going to get an answer for you as well. So give this a try. Yeah, this takes a little getting used to. I'm getting 2.30. How many places? 3 places. 2.3025. So I'll round that to 2.303. 3 decimal places. You able to get that? I think, unless I messed up. Let's see. That's right. Yeah, I think it's right. I think my answer's right. Notice those are LNs on the top and regular logs on the bottom. Yeah.
So LN without this is log.
It is, yeah.
And then log without this is just 1.
It's 10. Yeah, I'll show all that in a minute. Yeah. Are you guys getting that okay? In the calculator? Coming out? So, again, it's really important to know more than one thing, numerator, denominator, power zone, parentheses around. That's the only way the calculator will know you mean it's all in one zone. Unless if you have those fancier calculators that actually make it look like a fraction, then great. You don't need to mess with parentheses. It knows it. If it actually shows it vertical, then great. You don't need to mess with parentheses. It knows what's top and bottom just fine. But if you have, like mine, that's all on one line, then you got to tell it with extra parentheses what's really in the top and the bottom. Okay.
If the numbers were 50 and 2, and then 50 and 2, it's going to be 22.03, right?
No.
No? If it's set up the same because they're all equal? Right?
Oh, because they're all equal. I think it would still change. I'm not sure.
Because I got the same answer.
Okay, I guess it would.
Also.
Beyond my knowledge. I guess the answer is yes. I'm not sure why.
Worked.
Anyway, some fancy math proof I've got time for. Maybe we'll do it in a minute after we looked at. Oh, no, it's in 5.5, so yeah. Never mind. I guess yes is the answer. All right, so let's take a look at this one. So here we're going to start to see that exponentials like 5 to the. Notice how 5 to the x is exponential. And what does exponential mean again? Not just that it has powers,
X is in the power.
but x has climbed into power. Right? X has climbed into power. That's an important word that you know, especially for calculus. Exponential means x is in power. So for example, 2 to the x is exponential. Is x squared exponential?
No.
That's not exponential. Right? So it's about x being in power. So anyway, this is exponential, and this is log of the same base as the other thing is exponential. What that means is those are inverse functions. We're going to start to see what logs really are. If somebody would have asked me back when I was a pre-calc student, on the street, they would have just stopped me and said, hey, what is a log? You're taking one of those math classes. What is a log? I would have said, I have no idea in the world. I can do the little rules. I can move the little things around. But what is it? I have no idea. Well, I don't want to leave you that way. They're inverses of exponentials. That's what logs are. They're the inverse functions of exponentials. And we're going to see that right here. Let me get a fresh screen. My thing's off that screen a little bit today, isn't it? I'm going to have to watch out on the right edge. Okay. So, yeah, you only get half a D there. Okay, so let's take a look. So I'm going to just graph these things. So let's start with y equals 5 to the x. How do we graph that? You guys had the exponential chapter last night's homework, right? So let's graph that thing real quick. How do we graph 5 to the x? What number is added out here? 0. Which means what? What does that understood plus 0 out there mean? Yeah, that's the horizontal asymptote, which means it's got a flat asymptote at 0, right? Whatever the number added or subtracted off to the right of an exponential, x in the power, is your horizontal flat asymptote. Remember that? Real important. Okay? And therefore, you can just make a table real quick. X, y. Put in 0. What is 5 to the 0?
1.
1. So over 0, up 1. Right there. And put in 1. What is 5 to the 1? 5 over 1. Up 5, 2, 3, 4, 5. Good enough right there. So you always know they rocket on one side, flatten on the other, right? Exponentials always do that. They rocket on one side, flatten on the other. 2 dots is good enough for me to see which way it's going up. Other side it must be flattening. There's the graph of 5 to the x. Good so far? Now, on the same axis, they want me to graph log base 5 of x. Well, I'm going to graph it sort of by cheating. For sure, it's going to be the inverse function. That's what it's saying right here. Logs are inverses of exponentials. Now, what does a graph look like that's an inverse? You guys know, huh? It's a reflection across the diagonal line here. So if I was to take that graph and reflect it across the diagonal line, it would go like this, wouldn't it? It would go... Does that make sense? That'd be the log base 5. That's a reflection. So which one of those is doing that? It's like A. I just have my blue and my red switched. But A is showing that. Good there? Now, I was kind of cheaty there. I didn't really graph that log. I just said, hey, this is what it must look like because it's the inverse. In a minute, we'll actually plug in points and we'll graph them. And we'll see that that's actually true. That wasn't really a proof. That was me assuming it was true and just drawing it. We'll see it's true in a minute. Good so far? All right. All right, so what do the graphs of logs look like? If you have y equals log base b of x plus, I'm going to call it v. Is that a good way to do it? Yeah, I'll do it that way. That v is going to be the vertical asymptote. That the number in the parentheses of a log is where the vertical asymptote is. So when you go to the graph, there's a vertical asymptote at v. And the log graph goes like that. It takes a dive at the vertical asymptote wall. I think it's helpful, probably, to put the exponential right next to it. Remember exponential? B to the x times c plus a. A is the horizontal asymptote. Exponential graphs at A look like this, don't they? See how they're completely the opposite? Log graphs have a vertical asymptote. Exponential graphs have a horizontal asymptote. See how the exponential graph is concave up? It's a bowl turned up. See what I'm talking about? See how this graph here looks like a bowl turned up, whereas this graph is a bowl turned down. It's a slow growth, isn't it? Do you see that? See how the log is a slow growth? It is going up. It'll never stop going up. But it's going up very slowly. Bowl turned down. This is concave down. This is concave up. Fast growth. Powerful. Rockets up, right? X is in the power zone. Things happen fast. Whereas the log, super slow growth. Bowl turned down. And then it takes a vertical dive, whereas the exponential takes a flat dive. Okay. So with all that in mind, let's go for our graph. They're giving me this picture here, which shows a vertical at x equals 1. So doesn't that mean there's going to be an x plus 1 in the parentheses? It does, huh? Because, right, because I gave you the form, whatever the vertical is, it's added to the x in the parentheses. The base on all these is 3, so I'll just assume it's 3. We'll get to how we would know that later. But it's obviously 3. They're all 3. So I'll put that in as 3. Now, the only other thing on the one they're giving me is it looks like it's been flipped, doesn't it? Everybody seeing that? How has this one been flipped? Oh, it's off the screen there, isn't it? Okay, let me go to a fresh screen for you. And try again. Okay, so let me go back to the normal again. So this is normal log base b of x plus v. This is the vertical v, right? That's normal. So what's been done with ours? They flipped it sideways, haven't they, about the y-axis? Yeah, they've grabbed the y-axis, they've grabbed this, and they've turned it. Remember, whenever you're flipping graphs, you're grabbing an axis, like a barbecue rotisserie, and you're turning it, right? So they grabbed this y-axis and they flipped it, didn't they? Right? That's how it got to the other side. See how this graph is on the other side? But think about what will happen when you flip it. Not only will this piece move, but this dotted line will move. It'll move over here, and the graph will go like that, won't it? Do you see that? Now, that's not quite what we have here. Here, the dotted line's on the right, which means the dotted line was originally, before the flip, on the left. So see how I'm tracing this back? So what I'm seeing here, let me go. Originally, before the flip, that means we had some kind of graph with a dotted line over here that was going like this, and then they flipped. They grabbed this, and they flipped, and the whole thing came over here and is now going this way. See what happened? You guys tracking with me? They flipped it sideways like that, didn't they? It was originally, so this was originally -1, is my point. The vertical was originally -1, and they flipped it to become positive. The vertical moved as well under the flip, didn't it? Do you see that? So really we're talking about x minus 1 in the parentheses. Log base 3, and there's got to be a negative on the x, because that's what made the sideways flip. Too many details too fast? Yeah. Right? So two things. I want to make two things really clear. Number one, that graph has been flipped sideways. Right? The normal log graphs go up to the right, don't they? Up to the right normally. This one's going up to the left. So it's been flipped sideways, which means there's a negative on the x, right? You guys know what makes a sideways flip. Negative on the x somewhere, right? Good. Just forget about the one thing for a minute. Everybody good with that? There's got to be a negative on the x, because the normal log graph with no negatives anywhere, the normal case, goes up to the right, like all of our graphs basically do. They all go up to the right normally, unless they've been flipped somehow with negative signs, right? So the log, the exponential, I think all of our graphs normally go up to the right. This log goes up to the right normally, unless something's been flipped. And ours has clearly been flipped, because ours is going up to the left, so it's been flipped sideways. Sideways is negative on the x. So let's just look through here, process of elimination, and cut out the ones that don't have negative on the x. How about A? Is A okay? He looks good so far. He's got a negative on the x. How about B? Is B okay? Well, he's got a negative on the x, but he's also got to have some kind of a 1 in the parentheses because of our vertical. We have a vertical. Maybe we're not sure if it's a 1 or -1 because of the tricky flipping stuff, but at least there's some kind of a 1. Got to be in the parentheses. Can we all agree with that? That's what's making that vertical dotted line over there, so it's not B. He's got the negative x, but he doesn't have any kind of a 1 in the parentheses, added or subtracted. He needs to. You tracking with me? How about C? Is C possible? Why not?
There's no 1.
There's no negative on the x. There's no 1 in the parentheses with the log. No way. How about D? Is D good? There's no negative on the x. There's no 1 added or subtracted in the parentheses next. Remember, everybody see this vertical dotted line at 1. There's got to be a 1 at least added or subtracted in the parentheses with the x. That's where the vertical asymptote is. So no on D. How about E? It's got a negative on the x. That part's good. But there's no 1 added or subtracted in the parentheses. So he's missing that part. How about F? No negative on the x. How about G?
Yeah.
He's got the 1, but does he have negative on x? No. No, G's out. That's not a negative on x. How about H? No, he doesn't have negative on x. And by the way, that minus 1 is not in the parentheses. It's after the log. It's outside of the log. That's a y effector. That's not in the parentheses. That's not x is 1. So he's got double problems. So A it is. I don't even need to mess around. A is the only one that passed the test. He's got negative on the x. He's got a 1 in the parentheses. It's got to be A. We could plug in points to doubly verify.
If it's a negative one or a positive one?
Yeah, I would make a table. I told you the complex rule about originally it must have been on the left and the whole thing was flipped. And that's why it's on the right. So originally it was negative 1. So it's really in the parentheses
The
that.
current one is a 1, though.
Oh yeah, it is, huh? Yeah, see, it tricks me too. I just make tables.
Right.
I would just make a table. So I would just say, look, is that really right? Because on my test, you always get that none of the above option sitting there, right? So you want to make sure, hey, is it really A or is it just none of the above? Let's be sure. So what are you going to do to make your table? I'd plug in 0, plug in 1, some simple numbers. Let's do that. And so what do we get? Log base 3 of 1 minus x. So ready? Log base 3 of 1 minus 0. I plugged in 0 for x here. So that's log base 3 of 1. What is log base 3 of 1? I need to show you now how to do this on your calculator. Okay, so here's the other way. Do you guys have your calculators with you? Okay. Let's bring it up here. Log base 3 of 1. How are we going to do it? You guys have 2 log buttons on your calculator, don't you? Let me get a fresh screen here and we'll talk about it. You have 2 log buttons. You hit log of 100 for me real quick. Answer's going to be 2. Right? You getting that? Log of 100 is 2. Remember I said every log has 3 parts? Base, argument, and answer. What's the base? I don't see a base there.
1. I don't know. What is it?
10. So if no base is showing, that means 10 when no base showing. You remember this from algebra? Maybe not so much. It's called a common log. Common log. If there's no base showing, it means the base is 10. Now when you do ln, say ln of, I don't know what, 1 would be 0. What that doesn't show a base either. What's his base? What's the base of ln?
E.
It's E. E is base of ln. So there's 2 understood bases. Do you remember that from algebra? Every log really has a base. There's no such thing as a log without a base. Every log really has a base. If they give you the plain old log word and they don't show the base, it's understood to be 10. That's called the common log. That's just the one they use most commonly. Real life, engineering, things like that, when they use logarithms, the one they use most of the time is base 10. Just over time, they just grew tired of writing the 10. They just said, look, if I don't write anything, I mean 10. So that was the common log, the one used most often. ln stands for natural log. You kind of say it backwards, logarithmic, natural. It's a French word. The adjective comes after the noun kind of thing. Anyway, logarithmic, natural log, base E. It's that special number you learn more about in calculus. Base is E. So if they write ln, it means the base is E. If they write normal log and don't show a base, it's 10. But you can also write ln and make it 3 or whatever, right? You can do a different base. So every log has a base. Okay. So having that down clearly, I hope that's clear in your mind. How would you figure out log of 1,000? If somebody asked you log of 1,000, what would you do? What if somebody asked you log base 10? Let me do it that way. Log base 10 of 1,000. You would use that log button on your calculator, right? That log button on your calculator doesn't have a base showing, which means it's base 10. You get the answer 3 here, right? So then let me ask you this. What if somebody says, okay, now I want you to do the log base 5 of 1,000? How are you going to do log base 5? Do you realize you can't do any bases other than 10 or 8 unless I give you this trick I'm about to give you? Do you all see that? Do you see the problem? Otherwise, I'm not communicating with you at all. Am I coming across? Am I doing the Charlie Brown, the long? Am I reaching you? You can only do 2 bases on your calculator. There's only 2 buttons for logs on your calculator. One of them is the regular log word, which means base 10. Automatically means base 10. No getting around that. You hit that log button, you are assuming base 10. And I'm being asked base 5. Right? Or if you hit LN, you are assuming base E. No getting around that. Well, then how do I do log? There's going to be a million questions they ask us of logs that are other bases other than 10 or E. So how am I going to do logs of other bases other than 10 or E? Anybody know? Oh, yeah.
You put ln 1,000 divided by ln.
Or regular log. Either one. Yeah, you just make it into 2 logs. And you put the higher one up top and the lower one down below. That's the trick I wanted to show you on that.
There's actually a way to...
Yeah, and also there is a function under math or something like that.
Yeah, you click math, and then you click alpha, and then you click math again, and then you'll get where you're able to put the base for the one.
Good deal. Math alpha base or math alpha math or whatever. There's a way to do it in the calculator. And then here's the way for any calculator. Yeah, so that's called the change of base formula. Is everybody seeing that? Does that make sense? What answer do you get for that? What is log of 1,000 over log of 5?
1,000.
4.29? That's what I'm getting. And it goes on and on. Right? Y'all getting that okay? Kind of off the screen there. Oh, it's off the screen again, isn't it? Darn screen. All right. So let me show you again. So log of base 5 of 1,000 will be log of 1,000 over log 5, which is 4.29. Blah, 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 blah. Is that good? So we have to know how to do bases other than 10 or E. So 10 and E, we just use the button. But if they give us something other than 10 or E, make it 2 logs when, so you make it 2 logs when the base is not 10, not E. You guys tracking with me? So when they give you a log question where the base is not 10 and not E, then you have to do it by doing 2 logs. And a lot of times people ask me, they'll say, hey, Mr. Turner, how do you know which one comes first or second or whatever? Well, the higher one goes on top and the one that's lower goes in the bottom. Right? The bottom one goes bottom, the top one goes top. That's the way to remember. The order does matter. You've got to keep it that way. The top one goes top, the bottom one goes bottom. All right, so with all that said in mind, why am I showing you all that? Well, because back over here, right now, I've got to answer this question. Log base 3 of 1. I don't have a log base 3 button. See how that's a base other than 10 or E? So how am I going to do log base 3 of 1? The top one goes top, the bottom one goes bottom. You make it 2 logs, huh? And you should get the answer 0. Did you get 0? Good there? And then, for the next one, log base 3 of 1 minus 1. Right, I'm putting in 1 now. And that's log base 3 of 0. That's an error. That's a no. How are we doing? Have you forgotten about this problem completely after all this work? Am I losing you? So 0, 0. So the graph, the real graph, where's the real graph? It's just a mess now. Come back over here. The real graph should go through 0, 0. It does. And 1 should be no. Yeah, 1's a vertical asymptote. Beautiful. That's the right graph. That's the right equation. All right, let's try another one. Okay, so 14. So there it is. So remember the y equals log base b of x plus v. Here's your vertical asymptote, and it looks like that. That's the regular. That's the regular. So let me let you decide what's been done to the one they're giving us. What's been done to that thing? Has it been flipped? If so, how? Sideways, vertically? How's it been flipped? And not only that, what's the vertical asymptote? Remember how this is how we identified exponential graphs. We found out where the asymptote was and whether they've been flipped. Those are the two most helpful characteristics. Has it been flipped? Meaning, where's the negative signs? Is there a negative on x? Is there a negative in the front? Negative on x is a sideways flip. Negative in the front is a vertical flip. Has it been flipped? Has that graph been flipped from the regular? From the normal? Has it been flipped? And where's the vertical? So then just go through process of elimination once you've got those facts straight there. So first off, here's the normal. Normally they go up to the right. Has this graph been flipped? How's it been flipped? Has it been flipped vertically or sideways? Sideways, because now it's going up to the left, isn't it? Everybody good with that? It's not been vertically flipped, right? It's not going down to the left. It's still going up, but it's left. So it's been flipped negative on the x, hasn't it? Sideways. Is that off the screen? Yeah, flipped. Sideways flipped. So sideways flipped, negative on x. Everybody good so far? That one's been flipped sideways. Instead of going up to the right, it's going up to the left. So it's been flipped. So I'll look through those equations, and anybody that doesn't have negative on x cannot be the right answer. We could just eliminate it. So can it be A, for example? No. Doesn't have negative on x. Can it be B? B is possible. Can it be C? No negative on x. Can it be D? No negative on x. Can it be E? It's also got a negative in the front. Is that okay? No, that would be a vertical flip. And this thing is not, that would be, if you flipped this vertical, you'd grab this axis and it would be down like, it would go like that, wouldn't it? It would go down. That's not right. E's out. F. So you got negative on x? Yeah. G. Negative on x? Nope. Out. H. Negative on x? No. All right, so we're down to B and F. So which one is it, B or F? Can we tell? Think about the vertical. What's V? V is 0, isn't it? You with me? The vertical is 0. So what's the right answer? B it is. Not A. You can't have that 1 in there. There's no 1 in there. The vertical is not 1.
Is there a difference of 5 with the negative x in parentheses rather than just 5 with just a negative x there? Is that such a thing? I mean, is that
Yeah. If they wrote log base 5 negative, that would mean subtract x. Yeah. You got to put parentheses because otherwise it would mean subtract x. Yeah. It wouldn't even be such a thing. Yeah. Because you got to have a. Yeah, that would be subtracting x. You've got to have something right here. And if you put just x, you just put x, then that's fine. That's not added or subtracted. But if you have a sign, a plus sign or a minus sign, and you don't put parentheses, it means added or subtracted. And that's not what we mean. Yeah, so you couldn't do that. So B is the answer. This is a really long homework, but super valuable. I mean, you'll just look. If you do a good job on this homework, you'll learn so much about logs and exponentials. How to do it. So let me show you. Let's go through. I mean, I'll probably have time for like 2 or 3 at most. They take a long time because they ask you everything under the sun. You start with the original function. You graph. We're going to start with the original logarithm. We're going to graph it using what we learned about graph and logs. Then we're going to find the inverse using what we learned about switching x and y, solving for y. It'll turn out the inverse is an exponential. And then we'll graph exponential. And then we'll show that they're inverses of each other by the graph. So it's great. It just solidifies all those lessons we've been learning. How to find inverses, how to graph logs, how to graph exponentials. All that is really solidified. Domains and ranges, that's your domains and range for both of them. You'll see everything tie in together, but only if you put hours of your life into this homework will you so benefit. All right, so let's do it. So y equals natural log of x plus 6. First thing they want us to do is graph this thing. You can see I've already graphed it. So how would you graph it if you were to do it? What's I would probably just make a little XY table if I was to graph it. And yeah, let me help out. Do you know what is that plus 6 going to do? That. Oh, I told you the wrong information, didn't I? The vertical, I forgot. Everything I just said is not true. No, I'm just kidding. The vertical, I forgot. X is opposite. You guys are probably wondering about that. X is opposite. So the vertical is not plus 6. It's actually minus 6. Remember, X is always opposite? I forgot about that. So it's always opposite. So the vertical is at negative 6, isn't it? So right? So you guys see what I mean? So what I said is true. It's just the opposite number. So let me tell the truth now. So whenever you write ln of x plus v, the vertical is negative v, isn't it? It's opposite. So the vertical is opposite. So what's the vertical on this one? Negative 6. We good there?
So is it just for natural log or is it for all logs?
All logs, yeah. True for all logs. Yeah, so for all logs, yeah, it's just true for all functions. I forgot that x is always the opposite. X is always the opposite. So the vertical is negative 6 on this one. So the first thing I would do in the graph is go back to negative 6, and there's a vertical. So there's the graph back at negative 6. There's the vertical asymptote line. And then, so that's a crucial point, isn't it? When I go to make this equation, there's just no room here. I'm going to go to a fresh screen where we have room. So this is number 17. And it's y equals natural log of x plus 6. So the vertical is always the opposite of the number in the parentheses. So then when I go to make my XY chart, I know already back at negative 6 is the vertical asymptote line. So a good point to plug in is going to be 1 to the right of the vertical, or 1 to the left, right around the vertical asymptote line. Y'all tracking with me? Plug in things right around the vertical asymptote. So when I plug in negative 5, y will be the natural log of negative 5 plus 6, natural log of 1. You guys have your calculator? What's the natural log of 1? It's going to be 0. So that means that's the point back 5 up 0. We good so far? Everybody see what I'm doing? How about we plug in negative 4? Natural log of negative 4 plus 6. Natural log of 2. I have no idea what that is. It's going to be point something or other. 0.7, 6/9, so 0.7, which means back 4 up a little bit. All right, how are we doing? Am I losing you? This is really important stuff. I hope you're dialed in with me. You tracking with me? So everybody see what I'm doing now. I'm trying to graph this log thing. You look at the number added or subtracted in the parentheses for any log. Natural log, regular log, whatever, any base, doesn't matter. Any log, the number in the parentheses added or subtracted, the opposite is where the vertical dotted line is, the vertical asymptote. So I have a plus 6 in there. That means the vertical is at negative 6. Put that down first. So just like with the exponential graphs, we put the flat asymptote first. For the logs, we put the vertical asymptote. Be good to put that right on your 3x5 card. Put it this way, not the way I said it a minute ago, which was wrong. So put it this way on your thing. And then plug in a couple of points right near that vertical asymptote. Those are easy points to find. I went 1 to the right, negative 5, used my calculator, got 0, negative 4, got 0.7, got a couple of dots. So what am I going to do with these 2 dots? We know generally how logs look, don't we? So it's going to take a dive right there. They always take a dive at their vertical, and it's going to be slow growth the other way. Good enough. Those two dots, good enough. Does that make sense? We can go back and grab the right answer. Which one looks like that? It's already checked for us, A. Good so far on that. Now, let's go on to part B. From the graph, determine the vertical. Yeah, we've already got the vertical. X is -6. So that's obvious. Now that we have this graph, now we want to find the inverse function. Let's do that. I'm going to go to a fresh screen on this one. So 17 y equals natural log x plus 6. Find the inverse function. Okay, so how do we find an inverse function? What have we learned? Remember, we had a whole section on that, right? How do you find an inverse? There's 2 steps. What's the first step? Invert x and y and solve for y. Remember those 2 steps? You invert x and y, you solve for y. So I'm going to switch these guys. So x goes there, y goes there. Good so far? You with me? So I switch, so there's step 1, switch x and y. Now, you're trying to solve for y, right? That's step 2, solve for y. Can you guys solve that for y? How do you solve that for y? How do you get y alone? How are we doing? Any ideas? I'm trying to get y alone there. I'm trying to get y alone in that equation. How do I get y alone? What do? Could I do this? Here's what I've seen over the years, and you can probably already tell by my tone it's totally wrong. So the answer is no, you can't do it. But I've seen this a lot. Just divide off that natural log. Just boom. Then just subtract the 6. Don't write that down. That's craziness. But is it craziness to you? I hope. I hope that looks like funny farm mathematics. Wacko. Does it? It needs to look really crazy to you. Why is that crazy? Because that ln is not multiplying. That's not ln times y plus 6. That's not multiplying. It's a function. That's why I always do all the toaster talk. Because when I first started teaching math, many moons ago, I noticed that people didn't understand that these things are all functions. They were doing stuff like that all the time. In other words, this is like f of y plus 6 equals x or whatever. You can't divide off the f, huh? That's not times. That's plugged into the function. That's plugged into the toaster. That's not times. Do you get that? Really important that you got that idea. ln, e, all these things, sine, cosine, tangent, when we get to trig, all these things are functions. They're plugged into the toaster. They're not multiplication. It's f of something, for example. So we can't do that. Really important to know you can't do that. Okay, so that's what you can't do. What do you do then? How in the world am I going to... I do need to get rid of that ln. I got to get y alone. Y is here saying I want to be alone. Get rid of this ln, get rid of this 6, so I can be alone. Trying to solve for y. That's how we do it. What do we do?
Same thing as ln y plus ln 6.
No, yeah, you can't separate it like that. Yeah? No. All right, well, here's where we remember. What's the base on the ln? It's not showing its base. What's really invisibly there? E. You with me? Logs are what? Inverses of what? Of powers. They're opposite powers, aren't they? So let me ask you this, guys. What if you had square root of y plus 6 is x or whatever, and you want to get rid of the square root? How would you get rid of the square root? You would 2 power, and it would cancel because it's the opposite, huh? So what we need to do to get rid of that ln is bring the opposite. So what's the opposite of ln? E. Bye-bye. There it is. Did you see that? The opposite is an e to the power. Logs are inverse powers. Did y'all see that rule that I just did there? It's like square root, you bring in a 2 power or something. It's the opposite. It's what will get rid of the ln. You do the e power. Now, what if that was regular log? Let me double check, make sure this is making some sense for you. What if instead of ln, that had been x equals regular log y plus 6? How would I get rid of regular log? 10, because 10 is his base, huh? I would do 10 to both sides, now get rid of him. Yeah, so whatever the base is, you just do the power, because that's the opposite. Does that make sense? So it's just like a square root and a 2 power. They're opposites of each other. So if you've got one of them, you do the other, and that cancels it out. That gets rid of it. So that's what gets rid of it. And so what do we got then? Y plus 6 is e to the x. Now it's easy. How do you get y alone? Just subtract the 6. So e to the x minus 6. Boom. We got y alone. Does that make sense? Powers are opposite of logs. That's the moral of the story. Did you catch that? Powers are opposites of logs. Natural log, the opposite is e. Regular log, the opposite is 10. Power. That's what they are. All right, so that's the inverse function. That is the... So notice, e to some power is the inverse of natural log, like we talked about. Logs are inverses of power functions. So natural log is inverse of e to the x. Regular log will be inverse of 10 to the x. Won't it? All right, and I think now... Okay, so log base 5 of x equals 3. It wants me to solve. So here, starting at number 24, I want to solve log equations. So how do I solve that log equation? What do you do to solve that thing? You lose the log. What happens when you lose the log? Base stays the base. Other two switch. Instead of 5 to the x, it's 5 to the 3. X goes over there. Good. When you lose the log, base stays the base. Other two switch. Okay, then what's 5 to the third? Calculator tell you 125, John. 5 to the third power. Good? Questions? Okay, so log base 2, 5x plus 6 is 2. Try that one. Lose the log, base stays the base, other two switch. So lose the log, base stays the base. Other two swap. Instead of 2 to all that x stuff, it's 2 to the 2. And all that x stuff goes over there. Is that good? And then 2 to the 2 is just 4. Then you just solve for x. Subtract 6. So negative 2 is 5x. Divide by 5. Negative 2/5. We good? So you just lose the log, base stays the base, other two switch. Questions? Good. Log base x, 324 is 2. Same thing. Cross off the log, base stays the base, other two switch, x squared is 324. Good. So you just every time you just lose the log that way, right? You just lose the log, base stays the base, other two switch. Now how do you solve that for x? It's rooted, huh? So x equals, is it, I don't know what it is, 17? 18? 18. Good? Normally we would do plus or minus, but you can't, a base of a log can't be negative. So it's only the plus 18. All right, I'm going to all right, so ln e to the x is 8. So, yeah, that's a weird one, huh? Yeah. There's a couple of different ways. I don't know what's going to be the easiest way for you to think about this. One thing you could do is you could do what we just did in the last section where we were getting rid of log. How can I get rid of that ln? What would get rid of that? I could do e on both sides, huh? You could always do that. Or regular log, you could do 10. By the way, I could have done that back here. Let me show you that other way. That's another way that's totally valid. If you wanted to do 10 on both sides and just cancel that. Oh, no, that log is not a base 10. What's the base of that log? X. So you could have done x on both sides, yeah. And that would cancel out, and 324 is x squared. Yeah, that's the same thing, huh? Same equation. Whatever the base is, you can just power that on both sides, and it cancels it out. That's always valid. So right here, I can just do that. Isn't that good? Because the base is ln is e. So that leaves me e to the x is e to the 8. So x is 8. Did that make sense? So whenever you have a log, you can get rid of it with a 10 power. Or an ln, you can get rid of it with an e power. It's just the opposite.
Yeah, it's just the same as like if you wrote it as ln the base e to the.
Yeah, totally. That's the other way. Yeah, good thinking. Yeah, the other way is you could just do what I was saying with that rule, base stays the base, other to switch. There's really another e there. See, there's got to be a lower down number. There's another e. This e is on the level. He's not lowered down. So there's another lower down e, and when you cross off any log, natural log, regular log, any log, when you lose a log, base stays the base. Here's the other way. Base stays the base, other to switch. Instead of e to the x, it's e to the 8, and e to the 8 goes over there. Same thing. X is 8. That's the other way. That's why I was debating which way to show you. Either way, that's fine. I don't know which way makes more sense for you. If you want to get rid of a log base 2, what will get rid of a log base 2? 2 power both sides. You give us 2 power both sides. Or you could do why lose the log base is base other 2 switch. Either way. You give us 2 power both sides. Maybe that's the easier way to think about it. I changed to that way of talking in my business math class a couple weeks ago, and they did well in that exam. It made me think people think better that way. So, I don't know, does that seem more natural for you? You just 2 power both sides, and wham, that's all gone. That's just 4 is 2 to the x. Oh, wait a minute, what am I doing? What am I doing? I've got to think for a second. X is already alone. Hello? Why am I moving things around? X is already alone. You guys need to tell me that when I'm crazy. Say, Mr. Heron, what is wrong with you, buddy? X is already alone. Where are you going? Right? X is already alone. So hit the buttons on the calculator. Well, how do you do this one? We don't have a log base 2 button. What do? Make it 2 logs, huh? The top goes top, the bottom goes bottom. Hit the buttons on your calculator, it'll be 2. Done. X was already alone. I didn't need to move things around. Is that good? I was just kind of on autopilot there. I'm so used to just getting rid of those logs, just throwing those bases in there. I wasn't even thinking. X is already alone. That's how I drive. I drive on autopilot. My wife is nice to me. Sometimes if it's a family vacation or if we're going somewhere else, and I'm driving the van, we just get in the car, and I'll start going to work sometimes. And I'll just realize we'll start heading towards the freeway, and my wife will say, "We going to work today?" I'm like, "Oh yeah, it's Saturday or whatever," and then I'll think again. So that's what I was doing here, right? So the X is already alone. Whatever the price down has. All right, so hey, you know what I would do on this one? Is I would just do this right now in your calculator. It doesn't have any X's, it's just numbers. So the top goes top, the bottom goes bottom. It's 2. You getting that? Hey, if you want to know how I'm doing those like that, the rule for logs, if you want just like a quick way to do them, I don't know if you want more information or not, but really log, what it asks is power needed. Instead of power, it's power needed. So log, I just think power needed on a 3 to be 9. What power does a 3 need to become 9? 2. 3 to the second power. That's how I knew it was 2. I mean, you can just use your calculator, but that's what it is. It's power needed. What power, 3 to what power is 9? 2. That's how I know it's 2 over there. Anyway, then just finish solving for x, right? finish solving for x. Just subtract 1 from both sides, like that. We get 1 is 3x, divide by 3. Boom, 1/3. We good? Questions I can answer there? All is well? Is it wonderful? 17. E to the 4th. All right. How are you going to get rid of that e? What's the opposite of an e power? ln both sides. You get the hang of this? See how these guys are just opposites of each other? Like if you have a square root, you 2 power both sides. You got a 2 power, you root both sides. Right? They're just opposites. Like an acid and a base. They neutralize each other. Poison and an antidote. Right? So just ln both sides. What if this was 10 base? What if it was 10 to the 4x? Equals 6. Yeah, I would regular log both sides, wouldn't I? But this one is e, so I'll ln both sides. Making sense? They're opposites, and just bang, it's gone. 4x is ln 6. Good so far? Getting the hang of that these are opposites of each other? Powers and logs are opposites. So if you got one of them, and you want to get rid of it, do the other. If you got a log, you want to get rid of it, do the 10 power. So the divide by 4, ln 6 over 4. Do they want to? Oh, they want exact answers. They want it just like that. They don't want a decimal. They want it just like that. Is this making sense? Logs and powers are opposites, just like a square root and a 2 power. Okay, I'm going to keep. So e to the 2x plus 9 is 11. I know you know what to do. Get rid of that e, right? Get rid of that e. What's going to get rid of that e? ln both sides, right? Logs and powers are opposites. So if you got a power, do a log. If you got a log, do a power. Make sure the bases match. So I'm going to ln both sides. Cancels it out. They're opposites. So 2x plus 9 is... ln 11 is some ugly number. I'm just going to leave it ln 11 for now. Oh yeah, they want exact answer. So that means they don't want any decimals. They want you to leave ln 11 as ln 11. And then keep going. And so let's keep going. Subtract 9 from both sides. Now, that's going to be ln 11 minus 9. That 9 is outside. It's not plugged into the toaster, right? The 11, if that helps, you don't have to put those parentheses. But that's what it means. That 11 is plugged into the ln function. The 9 is outside of that, right? Last step, divide by 2. There's what they want you to type in. Just like that.
Is it the same if you move the 2 over? Like if it's, so you have ln 11 over 2 minus 9.
Like that? No, that 2's got to be underneath everybody. So you could write it like that. They could both have their own separate 2. Or one big bar, but the 2 is dividing, right? Because I divided the whole left side by 2. I've got to divide the whole right side by 2. Does that make sense? I don't want it just to be something Mr. Heron says. I want it to be something that makes sense. See, at this point, left side equals right side. So if I divide the left side by 2, I've got to also divide the whole right side by 2. The whole right side, both of them. One big bar or 2 separate, either way is okay. But the whole right side must be divided by 2. Good question. Other questions? Good. Okay, so these guys are all, you're getting the hang of this, right? These are opposites, right? Powers and logs are okay, so log base 3. X squared plus 4 is 2. What are you going to do? What are you going to get? You guys got a log. You want to get rid of that log? What are you going to do? Now here, what's his base? You always look at the base. You're going to do some kind of power, right? You get rid of logs by a power, but the base must match. So what power? What's his base? 3. 3 both sides. Not 10, right? Because he's showing his base. It's 3. So notice both sides like this, and wham. That makes sense? So whatever the base, you just do that power on both sides. So if he wasn't showing his base, we would know it was 10, or we would do 10. But he's showing the 3. So we do that. Powers and logs are opposites. And that's what, 9 over there? So x squared is 5. Last step, root it. When you put a roof on the house, up and down the ladder, plus or minus. So it's x is plus or minus. So the two answers are regular. The two answers, and it wants exact answer. So it knows it doesn't want a decimal. It's plus root 5, comma, minus root 5. Use a comma, it says. No parentheses.
You can't use the plus minus symbol? Or?
Oh, maybe they have. If they have a plus minus, probably do that. You can't have negative inside the log. That doesn't mean you can't put anything in negative. The whole inside can't be negative. Here's the whole inside. If I plug in negative root 5 there, this will be negative root 5 squared, which will be positive 5 plus 4 will be positive 9. The inside will still be positive. See what I'm saying? So notice, if there was just an x, if this was just log base 3 of x, yeah, then negative anything wouldn't be allowed. Because the straight inside would be negative in that case. That would be a problem. But because there's more to it than that, it's x squared plus 4, negative root 5 is okay because it comes out positive inside in the end anyway. So it's okay. Y'all tracking with that? So the whole inside can't be negative or 0. But negative root 5 doesn't make that happen, so it's okay. The sun's coming out. Winter's over. That was winter. It's last week. Good there. Five e to the 0.5x is 7. Okay. You know the deal. I would first divide that 5. Get rid of that 5 first. I would divide both sides by that 5. And then you know how you're going to get rid of that e, right? Once you get rid of that e, first get rid of the 5, divide by 5 on both sides. And then you're down to these, like peeling an onion. You start from the outer layer, right? You do the outer layers and work down to the middle. So you're starting with that 5. Get rid of that. Start with the outer layer. Boom, he's gone. Good so far. Now the next layer is this e. How am I going to get rid of that e? ln, right? ln both sides. Good. And those cancel. Those are opposites, right? Logs and powers are opposites as long as it's the same base. And that is ln is base e. See why I used ln there? Because it's e. It's the base e. So that gets rid of the e. And so what does that leave us? That is 0.5x is ln of 7/5. Last step to get last peeling of the onion. We just divide by the 0.5. Divide by 0.5. There's the one exact. Yep, they want that exactly typed in just like that. ln of 7/5 divided, the whole thing divided by 0.5.
It's okay to have a fraction on top of it.
I don't know. They'll probably take it. Would you know on a multiple choice test? What's that the same as? Anybody know? What's the cleanest way you could write that? Anybody got an idea? ln of 7/5. 0.5. What's 0.5? A half. And what can you do with a fraction in the bottom of a fraction? Flip it up to be 2 over 1. Remember that? Because dividing is upside down multiplying. Do you remember that? And I'm going to really put that in the front because it's not in the toaster. So it kind of looks confusing to put it in the back. So I'd put it in the front. It's 2 ln 7/5. Would you recognize that in a multiple choice test? That's the same. Do you see that? That's the same.
So John, we're going to do this one.
I have no idea. I don't even remember. Hey, look at that price tab. I'll do it already in that price tab. But yeah, I just get those off the publisher's website. So they do that trickery sometimes. They do. But really, I'm not interested in pulling that off because that's how well you need to know algebra to make any calculus. You need to be able to build those kind of rules. Because they do that all the time, and they whip things around, and if you don't know those rules, you're totally lost. It's algebra knowledge that makes you make it through calculus. So is everybody good with that? Half in the bottom, you can flip it up. Remember those rules and just put it in the front? That good? For us. So they're given P, well, I'm going to run out of room over there, aren't I? P equals 760 e to the minus 0.145 h. All right, so how's this work? They're telling me pressure is 381. Pressure is 381. So bunk. Just put in 381 right there. All right, we good to there? They just told me the pressure is 381. I just put in a 381 for P. Then it's peel the onion. Solve for H. This is kind of messed up here. So how do I, here's H right here. H is saying, I want to be alone. Peel the onion. Work all the way down to the H. What do I do first to get down to the H? Got to get rid of the 760, get rid of the E, get rid of the minus 0.145, huh? Just boom, boom, boom. 3 steps, layer by layer. Is that good? First step, divide by the 760. Get rid of that layer, bring it over here. 381 over 760 e to the minus 0.145h. Good so far? I'm just going to leave it as a fraction like that. All right, what's the next step? How do I get rid of the next layer? What's going to get rid of this e? I want to get rid of that e next, huh? I'm trying to work my way down to the h. How do I get rid of that e? ln, both sides. ln and e will cancel. So ln of 381 over 760 is minus 0.145h. Last step. Divide. Minus 0.145. Boom. H is alone. That good? Let's go back to one of those graph ones with our...
4 questions left.
Just as long as you know how to do it.
Yeah.
All right, so let's wrap with this one, and then we'll do the clicker quiz and be out of here. So this is these like 6, 7 questions in the middle where they have you do the original, the inverse, graph them both.
Oh, you were right.
All right, so first off, how do we graph this thing? Let's start with graphing. What did we learn today? First I taught you wrong, and now I'm trying to correct it to the right. How do you graph a log? What's the first thing you should do with that log? Yeah, let's find the vertical asymptote, but let's do it correctly. So what's the vertical going to be? Negative. Well, you'll never forget it now. It was effective teaching strategy, huh? That was my plan. Do it wrong and then correct it. I'm a genius. All right. So -1. It's the opposite, isn't it? So the vertical will be at -1. Okay? And then from there, I would just plug in a couple points, like x, y.
Is that -3 a y factor?
It's a y factor, yeah. But on a log, it doesn't look like, because they go up and down forever anyway. So it doesn't mean a lot, but yeah, it is technically. You're right. I would plug in points around, like 0. I'd plug in 0 because that's close. Put in 0, get log 0 plus 1 minus 3. Log 1 minus 3. If you use your calculator, that'll be 0 minus 3 minus 3. Over 0 down 3 right here. There's that dot. That's the vertical thing right there. I moved it down 3.
That's what I was wondering.
Yeah. Yeah, you're totally right. Yep, that's true. And then I plug in 1, whatever. I'm just going to say, you're going to get something like that. That'll be the log graph. You'll see that. What's already down there chosen, right? Oh, wait. Oh, that's part F. Yep. Okay, now it wants you to find the inverse. Can we do that real quick? Let's just wrap with that. So this is number 20. Y equals log, what is it? X plus 1 minus 3. Okay. So we got a minute and a half. Find the inverse. All right, can you do that one real quick? Find the inverse of that one. And we'll wrap with that. Find the inverse function. So you know what to do, right? Switch x and y, invert x and y, and solve for y. Invert x and y, solve for y. So swap these two. X is here, Y is here. All right, how do you solve for Y there? Hold on, guys. This is a valuable minute. I want to help you out with this. How do you get Y alone there? First, add the 3, huh? Is that good? Totally right. Add that 3. Get to here. Okay, now I'm peeling the onion. I want to get down to that Y. So what do I got to get rid of next? And what's going to do it? 10, because it has no base, which means 10. So 10 this side, 10 that side, whammo. Good? That making sense? So 10 to the x plus 3. And this is y plus 1. Then just move the 1 over. So 10 to the x plus 3 minus 1 is y. That's the inverse function, huh? Good? That all good? So we finished, sorta.
Ish.
Yeah, ish. All right, clickers are open. A for apple. And we're done. So even if you missed the first one, got 5 points, you get 10 for this. That's average of 775. Hang out if you got questions. Come see me or go to tutoring, get some extra credit. Do your homework there.
So